All right, so more talking about these lines, these words, tangent, secant, all that. Well, today is just all about tangents, which we have talked about tangents some, but it's just that line that touches the circle at one point. That's all a tangent is. So if you have a line touches the circle at one point, one thing that is a property of it is it when it touches the circle, if you also have a radius there, if the radius touches the point of tangency, it will be perpendicular every single time. So this is like a theorem, which I usually don't use that word because it scares people. But this theorem talks about how the tangent line will always be perpendicular to this radius, and therefore you can use Pythagorean theorem with that if you have right triangles here. See, radius, tangent line, and then just connect the two at the center, and then you have a right triangle. So let's go down here and we can use Pythagorean theorem for this. All right, so if you see something like this on the picture, and here's the deal, and here's what gets confusing about these questions, is like you have to know what to do for which question. Because the way this works, you've got question, you've got triangle, triangle, triangle. You just have to be able to look at the picture and know that it's a right triangle based on this is a tangent and this is a radius. But kind of see how these pictures can look similar to these pictures. You just have to figure out what it's asking for. So this is talking about angles. These are talking about sides. So that's how you know the difference. All right, let's do some Pythagorean theorem. So I've got a squared plus b squared equals c squared. For this one, my a and my b are 9 and x. So 9 squared plus x squared. My c squared is kind of weird. So look and see what's happening here. And this is what kind of confuses people. They look at it and they're like, whoa, whoa, whoa. What's going on? Is 8 the whole thing? What is 8? 8 is just from the edge of the circle to this point where, you know, these two lines intersect. So what is it going to be from the circle to the center? Does anyone yeah, it's 9. It's literally the radius. Not that confusing, but if it's not written on there, people struggle with it. So this is going to be 9. How did I know that? Because it is the radius. The radius is the same here as it is here. So this whole thing is going to be 17. How do I know that? 8 plus 9 is 17. So 17 squared. All right, so I'm going to take 17 squared and I'm going to subtract 9 squared. Why am I subtracting 9 squared? Because I want x all by itself. It does not want to have to share this side with 9. So bring that x squared down. Make sure you're doing squared and not just 17 minus 9 because you're going to get it wrong if you just do 17 minus 9. You get 208. Yes? What did I just do? 17 squared minus 9 squared. I got 208. And then I have x squared equals 208. My last step for Pythagorean theorem is always to take the square root. Square root of 208 is 14.4. We are not going to simplify radicals. We are just going to put this in a decimal. That's all you're doing. You are solving for x. And then you need to look at the picture and make sure, okay, is x what I'm looking for? Yes. All I'm trying to do is find x. So that's my answer. All right. Let us do another one. So this one right here, 8 is here. This is 5. All right, I'm going to pause for a second because I want you guys to set this up and solve essentially the same as the one before. So we have a squared, b squared, c squared. How do I know 13 goes there? Because it is across from the right angle. How do I know where the right angle is? It is where the tangent line intersects with the radius. It's also just the one that looks like a right angle. That's, you know, another thing. So we're going to subtract 5 squared on both sides. 13 squared minus 5 squared. Oh, I had it. Oh, I guess I did it in my head. Yeah. So you end up getting 144. But, I mean, if you put it in your calculator, that's what you get. And then square root is your last step. So the square root of 144 is 12. And that's all you're doing. All right, let's look at one more type of problem that you may see. We have 8 here. 8 is the radius, but you need to find the diameter, the whole thing. So one thing you have to realize that is if 8 is the radius, the whole thing is going to be 16, or the diameter is going to be 16. So 13 squared plus 16 squared equals x squared. So how do I know that, like, x is where it is? There's my right angle. If I write that in there, where the radius, it's technically the diameter, but also the radius, and the tangent line meet, that's a right angle. So that x is your hypotenuse because it's across from the right angle. So you have to put that right angle in there. That's really probably the trickiest part. Okay, and then for this one, I cannot tell you how many times people look at this and want to do 13 squared minus 16, or 16 squared minus 13 squared because of the last two problems. This one's different. This is why we write this out. We write this out. We don't just look at it and try to, guess, but it's easy to see. It's on the same side of the equation here. So you get 425 equals x squared, and then our last, I got a little crazy with the x. Okay. I don't know why this says squared. 425, is it? Not squared. 425 equals x squared. Take the square root of both sides. 20.6 equals x. That's all you gotta do. Alright, let's go to the next page. So if you get a picture that looks like a snow cone, and this is kind of how I always look at these. Looks like a snow cone, right? Like if you turn it, like the little cup and then the snow ball on top. Those two tangent lines are going to be congruent to each other. Always. This is another theorem. The first one we talked about was the whole right angle with the radius. This is the second theorem we're talking about today, and it simply is just something that has been proven that anytime you have two tangent lines, they are going to be congruent to each other. Two tangent lines that intersect. So two tangent lines, they intersect. They're always going to be congruent. This is a plus sign, just make sure you guys can see that. X plus 6 equals 4x. So we're going to subtract x on both sides. Why am I doing that? Well, because this is x plus 6, don't divide by x just yet. We will divide by 3 and get x equals 2 as our final answer. Sorry, that was kind of covered up, my bad. But yeah, you're going to subtract x on both sides. And then you have 3x equals 6, divide by 3. 6 divided by 3 is 2. I mean, you're just setting equal and solving. Not really overly complicated. Alright, and then we're going to look at this problem. I'm going to take my highlighters. And here's what I'm going to do. Each of these points, I'm going to highlight the two sides that create those points. And then, if you don't have a third highlighter, you can do whatever you want. You can, mark these as congruent. That could work as well. You could make little squiggles. If you have a colored pen, you can kind of, show them as congruent. It doesn't really matter, but what we just talked about before was the fact that these two sides that intersect are congruent. So that also works with the perimeter if you have a shape. So the circle is inscribed within this triangle. But all of these are tangent lines. So this is 2, that's 2. This is 8, this is 7. They match each other. Okay, where do people mess up typically? So many people want to make this 8 and this 8. I don't know why. But these two match, these two match, these two match. But I cannot tell you how many times people put 8, 8, 8, and then 7, 2, 2. And then they get it wrong. The two sides of the points that come out are going to be congruent to each other. And that's always going to be the case. So now for perimeter, you're just adding up the sides. 8 plus 8 plus 7 plus 7. It's 2 plus 2. You add them together, and you get 34. And then you're done. That's the perimeter. So the perimeter, add the sides. Yeah. Add the sides together. That's what perimeter's asking you to do. Alright, the only tricky thing is sometimes you may have, so let's highlight these sides again. Sometimes you might end up without, I'm going to take my pink pen, so that these are the same. Or you can just put congruent symbols on them, that would work as well. Alright, so we know that both of my yellows are 9. Alright. That makes sense. But then that's all that's like we don't have both sides of the orange. We do have that this side of the pink is 8.7, so that means this is 8.7. And then you have something that we learned back in August. So this is segment addition where you have the whole thing and then you have part of it, but you just want the other part. So all you have to do is take 14.2, which actually may write it up here instead. We're going to move this up here. You're going to take 14.2, you're going to subtract 8.7 from it. Why am I doing that? Because I want to figure out what the orange part is. So 14.2, nope, don't want that. 14.2 minus 8.7. Yeah, thank you. 5.5. So that's my orange. This is my other orange. Now we have all the oranges. We have all the pinks. We have all the yellows. Here's the problem, and here's the last thing that sometimes people mess up on. People want to add the 14.2 and the 5.5 and the 8.7. But you only need, you got to pick one of them. So personally what I like to do is cross this one out. And it's up to you. If you want to cross these two out and just use the 14.2, it's the same. But in my brain, it just works better to do 2 of the same thing 3 times. So 2 5.5s, 2 8.7s, 2 9s. But if you want to substitute out one of the 5.7s and one of the 8.7s, or 5.5s and 8.7s for the 14.2, absolutely go for it. I just have learned that I make mistakes when I do that. So we're going to take 5.5, do 5.5 again. 8.7, do 8.7 again. So I took my 2 pieces of every side, I added them together, and I get 46.4.